The statement largest motor 25% suggests that it comes from 430.24, which states that 125% is incorrect. National Electrical Code Section 430.24 deals with the calculation of the minimum size for service that supplies a dwelling unit and its associated loads. It does not provide information about the percentage of load that is contributed by the largest motor. National Electrical Code Section 430.24 states that the minimum service load shall be 100 amps for one-family dwellings and 100 amps for each dwelling unit in two-family or multi-family dwellings. National Electrical Code Section 430.24b provides an optional calculation method for sizing the service load based on the following formula: minimum service load equals 125% of fixed load plus variable load. The fixed load includes items such as lighting, appliances, and receptacle loads. The variable load includes items such as air conditioning and heating equipment. The 125% factor in the formula is a safety margin to ensure that the service is adequately sized to handle the expected load. Therefore, the statement largest motor 25% suggests that it comes from 430.24, which states that 125% is a misinterpretation of the National Electrical Code. When sizing a service for a dwelling unit, it's important to understand how to properly apply the National Electrical Code requirements. Calculating the service load accurately ensures the electrical system can safely handle the anticipated demand. Let's break down the relevant sections of the National Electrical Code to clarify the process. Firstly, it's crucial to recognize the National Electrical Code Section 430.24 doesn't dictate a specific percentage contribution from the largest motor to the overall service load calculation. It primarily addresses the minimum service size for dwelling units. Secondly, National Electrical Code Section 430.24 sets the baseline requirement for dwelling units. Specifically, it mandates a minimum service load of 100 amps for single-family homes and 100 amps for each dwelling unit in multi-family buildings. This provides a starting point for ensuring adequate electrical capacity. Thirdly, National Electrical Code Section 430.24b offers an alternative calculation method. This optional method allows for more precise sizing of the service load, taking into account the specific loads within the dwelling. The formula employed is minimum service load equals 125% of fixed load plus variable load. To effectively use this formula, it's necessary to understand the components of fixed and variable loads. Fixed loads typically encompass continuous electrical demands such as lighting, general-purpose receptacles, and permanently installed appliances. Variable loads, on the other hand, represent intermittent or fluctuating demands such as air conditioning, heating, and large appliances like clothes dryers. The 125% factor applied in the formula serves as a safety margin. This percentage increase accounts for potential overloads and ensures the service can accommodate unexpected surges in demand. It's not related to the specific contribution of the largest motor. The statement claiming the largest motor contributes 25% and is derived from National Electrical Code Section 430.24, which states 125%, is a misinterpretation. The 125% factor in National Electrical Code Section 430.24b applies to the entire calculated load, not a specific motor contribution. To properly size a service considering motor loads, refer to Article 430 of the National Electrical Code, which deals specifically with motors, motor circuits, and motor control. Article 430 provides detailed guidelines on calculating the ampacity of conductors, sizing overcurrent protection devices, and determining the contribution of motors to the overall load. When dealing with motors, you typically calculate the full load current of the motor from its nameplate rating. For service calculations, if you have multiple motors, you usually consider the largest motor at 125% of its full load current plus the sum of the full load currents of the other motors. This accounts for the potential starting current of the largest motor. In summary, sizing a service load for a dwelling requires careful consideration of the National Electrical Code requirements. Accurately identifying fixed and variable loads and applying the appropriate safety factors is essential. Remember that the 125% factor in National Electrical Code Section 430.24b is a general safety margin, not a specific motor contribution. Always refer to Article 430 for detailed guidance on motor load calculations. A thorough understanding of these concepts will help ensure a safe and reliable electrical system for any dwelling unit. Always consult with a qualified electrician or electrical engineer for specific project requirements and to ensure compliance with all applicable codes and regulations. The National Electrical Code is a comprehensive document, and its proper interpretation is crucial for electrical safety. Before undertaking any electrical work, it is essential to thoroughly research and understand the relevant code sections. Misinterpretations can lead to dangerous situations and costly mistakes. When sizing a service for a dwelling, one must consider all applicable loads. Firstly, lighting loads are calculated based on the square footage of the dwelling. The National Electrical Code provides specific guidelines for minimum lighting load requirements per square foot. Secondly, small appliance circuits must be factored in. Typically, 220-amp circuits are required for kitchen and dining areas to accommodate the numerous small appliances used in these spaces. Thirdly, laundry circuits are essential. A dedicated 20-amp circuit is required for the laundry area to handle the high power demands of washing machines and dryers. Fourthly, individual appliances such as refrigerators, dishwashers, and ranges must be accounted for. The nameplate ratings of these appliances indicate their power consumption, which must be included in the load calculation. Fifthly, heating and air conditioning loads are significant and vary depending on the type of system used. Electric heating systems and air conditioners draw substantial current and must be accurately calculated. Sixthly, electric water heaters are another major load. Their power consumption depends on their size and heating element wattage. Seventhly, any additional fixed appliances such as garbage disposals, microwave ovens, and built-in ovens should be included. Their nameplate ratings provide the necessary information for load calculation. Eighthly, if there are any outbuildings or detached garages, the loads must be considered separately and added to the overall service load. Ninthly, electric vehicle charging equipment is becoming increasingly common. The load for EV chargers can be substantial and must be carefully calculated. Tenthly, any other specialized equipment or loads, such as swimming pool equipment, hot tubs, or workshops, should be included in the calculation. Once all individual loads have been identified and calculated, they are added together to determine the total connected load. However, the National Electrical Code allows for demand factors to be applied to certain loads, recognizing that not all loads will be operating simultaneously at their maximum capacity. Demand factors reduce the calculated load, resulting in a more realistic estimate of the actual demand on the service. For example, a demand factor of less than 100% may be applied to the total lighting load, recognizing that all lights are unlikely to be on at the same time. Similarly, demand factors can be applied to appliance loads depending on the number and type of appliances. After applying all applicable demand factors, the resulting value is the calculated load. This value is used to determine the minimum size of the service conductors and overcurrent protection devices. It is important to select conductors and overcurrent protection devices that are adequately sized to handle the calculated load, while also providing protection against overloads and short circuits. The National Electrical Code provides tables and guidelines for selecting the appropriate conductor sizes and overcurrent protection device ratings based on the calculated load and other factors. It is also essential to consider voltage drop when sizing service conductors. Excessive voltage drop can lead to reduced appliance performance, flickering lights, and other problems. The National Electrical Code recommends limiting voltage drop to a certain percentage of the nominal voltage. The length of the service conductors and the amount of current they will carry affect the voltage drop. Therefore, longer conductors and higher currents require larger conductor sizes to minimize voltage drop. In addition to sizing the service conductors and overcurrent protection devices, it is also important to properly ground and bond the electrical system. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Bonding ensures that all metallic parts of the electrical system are electrically connected, creating a low impedance path for fault current. The National Electrical Code provides detailed requirements for grounding and bonding, which must be followed carefully to ensure electrical safety. The service entrance equipment, including the service disconnect and overcurrent protection devices, must be properly installed and maintained. The service disconnect allows the entire electrical system to be de-energized for maintenance or emergency purposes. The overcurrent protection devices, such as circuit breakers or fuses, protect the conductors and equipment from overloads and short circuits. It is important to regularly inspect the service entrance equipment to ensure that it is in good condition and functioning properly. Any damaged or defective equipment should be replaced immediately. Proper labeling of circuits and equipment is also essential. Each circuit breaker or fuse should be clearly labeled to indicate the loads it serves. This helps to prevent confusion and makes it easier to troubleshoot electrical problems. The service entrance equipment should also be labeled with the voltage, amperage, and other relevant information. Electrical safety is paramount. Always exercise caution when working with electricity. Never work on live electrical circuits. Always de-energize the circuit before working on it and verify that it is de-energized using a voltage tester. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. The National Electrical Code is constantly evolving, and it is important to stay up to date on the latest requirements. The National Fire Protection Association, NFPA, publishes the National Electrical Code every 3 years. It is essential to use the latest edition of the National Electrical Code to ensure compliance with the most current safety standards. In summary, sizing a service for a dwelling requires careful consideration of all applicable loads, demand factors, voltage drop, grounding and bonding, and the National Electrical Code requirements. It is a complex process that should be performed by a qualified electrician or electrical engineer.